The universe that I exist in is a very good, high-quality simulation.
And then that world creates a world in its country. And then you have simulations all the way down.
No, there's a 1 in billions chance that this is base reality.
Maybe you or somebody else creates an AGI system and you get to ask her one question. What would that question be?
What's outside the simulation?
This is not a fringe idea anymore. Some of the greatest thinkers of our time, philosophers, physicists, futurists, all wrestle with one haunting question. What if everything we know is just a simulation? Not a metaphor, not a sci-fi story, but reality itself.
If that sentence feels disorienting, that is the point. Humans have always asked whether appearance matches truth. Plato asked it 2,500 years ago. René Descartes asked it in the 1600s. Today, the question returns, but with new language, algorithms, computation, rendered worlds. The tools have changed, but the doubt is the same. How do we know what is real?
In 2003, philosopher Nick Bostrom gave the doubt a startling new shape. He framed the problem with probability and technology, asking us to count possibilities. His idea did not invent the suspicion, but it made it hard to dismiss. If civilizations can create lifelike simulations, and if they would run many, then the odds tilt. The simulated might massively outnumber the original. And probability, he said, is not an innocuous thing.
Those voices make the idea feel urgent and curiously plausible. But to understand why, we must walk through the argument carefully, step by step.
Nick Bostrom's claim is structured as a trilemma, 3 exhaustive, mutually exclusive possibilities, at least one of which must be true. 1. Civilizations never reach simulation-level technology. Some futures end before advanced computing becomes possible. Civilizations might collapse from climate catastrophe, war, resource depletion, or self-destructive technology. If that is the universal pattern, then no one ever runs the kind of simulation that creates conscious, detailed ancestral worlds.
Either we're going to create simulations that are indistinguishable from reality, or civilization will cease to exist. Those are the 2 options.
2. Civilizations refuse to run ancestral simulations. Even if the technical capacity exists, advanced societies may choose not to simulate conscious beings. Reasons could be ethical, a moral horror at creating suffering, or practical, a lack of interest, legal restraint, or resource allocation to other priorities. If every civilization with power chooses restraint, then simulations of our kind never happen. 3. We are almost certainly in a simulation. If technologically mature civilizations do run ancestor simulations, and they run them many times over, then simulated minds would vastly outnumber the biological base reality minds. From a probabilistic standpoint, it becomes overwhelmingly more likely that any given mind, including ours, is inside a simulation.
Bostrom's point is not that we definitely live in a simulation. It is a logical framing. Given certain assumptions about technological survival and the choices of advanced societies, the simulated scenario can become the most probable. The argument forces us to reckon with probability when it comes to ontology, with counting, not only with metaphysics.
2 clarifying notes. First, the argument is conditional. It says if certain things hold, then we should assign a high likelihood to being simulated. Second, the trilemma does not prove who the simulator is, their motives, or whether they are even conscious. It only reframes our epistemic situation. We may be one among a vast population of simulated minds.
Let us imagine, briefly, what a simulation capable of producing conscious beings might look like. Today's virtual environments are crude by comparison. Video games simulate physics, AI agents follow scripted patterns, rendered scenes mimic light and shadow. Yet, compute power grows. graphics go from polygonal to photorealistic. Machine learning models now generate voices, faces, entire scenes. Extend that progress for centuries, perhaps millennia. Suppose future computers have orders of magnitude more processing power than ours, architectures we can barely conceive. They might simulate neurons at biological fidelity, or they might run higher-level emulations that produce functional consciousness without simulating every ion channel. From the inside, the beings in such a simulation would have memories, sensations, history. To them, the world would feel continuous and real. They would invent science, art, and philosophy. And unless the simulators reveal the artifice, those beings could never distinguish their constructed existence from base reality. Many of the scientific observations that fuel simulation speculation are not proof, they're analogies. Yet the analogies are compelling. First, quantization. At the smallest scales, physics does not allow arbitrary continuity. The Planck length and Planck time define the smallest meaningful units. Space and time may be discretized, a kind of lattice beneath apparent continuity. This looks, superficially, like pixels on screen.
What happens if you try to approach something that's the Planck length? You get so much energy in there that what you do is you form a black hole. And then you put more energy in, you try to see what's going on, and the black hole grows. And so you get to a point, which is around the Planck length in size, where you can't, in principle, try to resolve the structure of this thing. It starts to go bigger again, because you make a bigger and bigger black hole and it grows. So the Planck length does seem to be, I would say is, a fundamental property of the universe.
Second, quantum measurement. Particles inhabit probabilities, superpositions, until an observation collapses the state. The double slit experiment vividly illustrates this. Electrons behave like waves until a detection event forces a particle-like result. Some read this as a render-on observation behavior. While researching all of this, the double slit experiment, the idea of a universe that renders on demand, my mind just broke. It led me to a question I never expected to ask, one that feels both radical and deeply personal. This isn't about God being absent or uncaring. It's the opposite. It's an act of ultimate respect. Think about it. If God were a constant observer, a divine hand always on the scale of our lives, would our free will truly be our own? If he's always there, ready to collapse our potential and choose a path for us, are we really free to choose? My mind went to this incredible, terrifying place. Maybe God's greatest act of love wasn't creating us, but letting us go, releasing us into the universe with all our potential, like that unobserved electron. He gave us the canvas, the brush, and the colors, and then he stepped back. He trusts us to be the observers of our own lives. He trusts us to collapse the wave of our potential and choose our own reality. This completely shifts everything I thought I knew about faith. The reason we can't get a clear, undeniable sign might be because a sign, by its very nature, is a form of observation. It would collapse our potential and rob us of the chance to choose. So maybe, just maybe, God isn't ignoring us. He's allowing us to be the creators of our own destiny. His silence isn't a lack of presence. It's the ultimate form of trust. It's the permission to be truly, terrifyingly, beautifully free. It's the ultimate expression of love. Whether you see it as science or faith, the experiment points us to bigger questions. And that leads us to the next piece of the puzzle. Third, limits and constants. The universe has finite energy, finite particle counts, and fixed physical constants. A computational substrate would likewise be bounded. Physicists probe these bounds with instruments and clever thought experiments.
These features do not logically imply computation. Many theories of fundamental physics would also produce similar observations, but
The parallels give researchers ideas for possible signatures, small anomalies, correlations, or patterns that differ from what standard continuous theories predict. If reality is a computation, could we detect its seams? Scientists have proposed a handful of clever tests. One concept: search for anisotropies in ultra-high-energy cosmic rays. If space-time were discretized on a lattice, particle interactions at extreme energies might reveal directional biases, tiny fingerprints of the underlying grid. Another idea: look for numerical artifacts, statistical irregularities that can't be explained by known physics. A simulated universe might economize resources. Not all regions would be computed at the same fidelity. Observational selection effects might leave telltale traces. A third is the debug hypothesis. Seek improbable, repeatable anomalies, events that seem to reset the state or contradict established laws. Such anomalies could, in principle, signal intervention or correction. But each proposed test faces deep obstacles. First, the instruments we have access to probe a narrow band of scales. Second, any anomaly we find may have many explanations within standard physics, unknown forces, measurement error, or novel phenomena. Third, and most troubling for detectability, our simulators could have anticipated scrutiny. If the simulation is designed to conceal itself, tests will either be blocked, explained away, or curated. The testability problem pushes the simulation idea to the border of science and philosophy. It remains an intriguing possibility, but not yet empirically anchored.
So he made a universe, and that guy is from that universe, and that guy made a universe, and that's the universe where I was born, where my father died, and where I couldn't make time for his funeral because I was working on my universe.
Before computing existed, cultures already described reality as veils and shadows. Hinduism names the illusion Maya, the transient, deceptive surface of things. Buddhism teaches about anatman and impermanence, calling attention to the mind's construction of experience. Gnostic traditions imagined the material world as a flawed creation hiding a deeper truth. Modern fiction recasts these motifs with machines. The Matrix made the metaphor literal, humanity living in an engineered dream. Black Mirror explores moral consequences of layered realities. These stories matter because they give texture to the abstract argument. They let us feel, not just reason, the implications. Suppose for a moment that the simulated hypothesis were true. Would love still matter? Would suffering still be wrong? Would beauty still be beautiful?
So here's the haunting thought. If meaning is grounded in lived experience, in the laugh of a child, in the tremor of an old hand, does it matter what substrate those experiences run on? Would pain hurt less if it were code instead of flesh? Would joy feel less real if it was simulated? Or is reality defined not by what it's made of, but by what it feels like to live it?
Yet new moral questions arise. If simulated beings can suffer, what obligations do creators bear? If designers can create worlds with conscious inhabitants, do they have duties to minimize harm, to ensure dignity? As artificial intelligence matures in our time, similar questions become urgent about our own creations. The simulation argument forces us to confront the ethics not only of our lives, but of our possible role as future creators. There is another layer, psychological and social consequences. If a large portion of a society believed absolutely it was simulated, the effects on motivation, law, politics, and care could be profound. Some might retreat into nihilism. Others might double down on compassion, treating every experience as sacred precisely because it could be fleeting or constructed. The simulation hypothesis has powerful critics. One common critique is unfalsifiability. If any anomaly can be attributed to simulator design, then the hypothesis explains everything and predicts nothing. Such a theory risks becoming metaphysics, not science. Another critique challenges assumptions about future civilizations. Bostrom's probability rests on contingent claims about survival rates, cultural choices, and computational appetites. We have no empirical basis for projecting such trajectories. Civilizations might universally self-limit or prioritize different values. A third critique points out regress problems. If our simulating civilization itself exists inside a simulation, we can imagine infinite layers, a hall of nested worlds. Probability arguments must then carefully consider how many layers exist. Counting brains across an infinite regress becomes ill-posed. Finally, some philosophers propose a pragmatic reframing. Whether or not we are simulated has little bearing on the lived norms of science, ethics, and politics. We must act in the world as it presents itself, using the best methods at hand. Questions like this are valuable whether they're true or not. They sharpen our epistemic humility. They force us to test assumptions. They push physicists to design clever experiments, philosophers to re-examine reasoning, and artists to imagine new forms. The simulation question becomes a mirror. Looking outward, we end up asking how we know what we know. So what are we to do with the possibility that reality might be engineered? We can panic, we can dismiss, or we can attend to love, to curiosity, to the little lives that unfold within whatever frame contains them. If we are simulated, we are simulations who ask. If we are base reality, we are tiny observers in a vast cosmos. Either way, our asking is itself remarkable. This capacity to reflect, to wonder, to create meaning from mystery, it may be the most important fact of all. Do you want to know? If you already believe, how would you live differently? If you're skeptical, what evidence would change your mind? Wherever you stand, the question persists, and in its persistence, it keeps us searching, learning, and human.
Every religion basically describes what? A super intelligent being, an engineer, a programmer, creating a fake world for testing purposes or for whatever. But if you took the simulation hypothesis paper, you go to jungle, you talk to primitive people, a local tribe, and in their language you tell them about it. Go back 2 generations later. They have religion. That's basically what the story is.